Hello, dear grade 10s. I'm sorry I'm not there to teach you today, but I thought maybe I could just go through these examples, which I was going to go through with you in class. So I'm sorry if the sound isn't great and if my writing isn't great. I'm working on a different computer, so it's not so easy to write on. So first of all, let's have a look. A couple of things that you should know already and should have a note on is this thing here. I've done this. That's a very fat cookie. About the fact that parallel lines have the same grade. Now, that's something we've known since grade 9, and that's something that you've written a note on, so that should be fine. Next thing, something you should know, is that the gradient of a straight line is y equals mx plus c, where m represents the gradient, and we have now this formula is given to the formula, and we did practice it in class, and then c is the line set. How often, what you'll notice how we find the line is we sub in the point. Sometimes once you know the gradients, you can always, once you only have one unknown left in an equation, you can always sub in a point to solve for that. So we'll see that in our examples, and then we'll see it and we saw it in class today. Okay, and then what we kind of saw in class today, but we didn't quite finish, is this statement here, which is really important. If two lines are perpendicular, then the gradients of one of them multiplied by the gradients of sorry. Basically what you need to know is, you know how in geometry we one-way implication, two-way implication. Then like Pythagoras, a right angle triangle, and the converse is true. If a squared plus b squared equals c squared, then it's right angled. Now this is the same idea. So if lines are perpendicular, then implies that the gradient of the one times the gradient of the other equals -1, which is a very useful concept. The reverse is also true. Therefore, if I had to prove that lines are perpendicular, I can now just show -1. That means that now that's going to be quite important, because up until now, the only way for us to prove that lines were perpendicular would be in a right angle triangle to prove that Pythagoras existed. Whereas now we've got a much faster method, so we'll see some of the examples which do that. So we'll see some of these examples as we go. The most important thing to remember is that if you're trying to prove something, you have to show that this is true. You can't assume it's true. So if you know they're perpendicular, you're allowed to assume that this statement is true. If you're trying to prove they're perpendicular, you would have to prove that that statement is true. So we'll see examples. Okay, let's look at our first example. This question says ABCD is a quadrilateral. I've got a cough. So there we go. There's ABCD. It's a quadrilateral, and it doesn't tell you which quadrilateral it is. So there's no way for you to know that it's a parallelogram or rhombus or a rectangle. And so the only thing you know right now is that it's a quadrilateral. The first question says prove they're parallel. Now this is an important question because you can't assume they're parallel. You have to prove they're parallel. So what I would do here is I would find the now because you don't actually have to show the formula, but you have to. So I would do 4 minus 1, which becomes plus 1 over 10. So just so you know there, I've just done changing 1. That equals 5 over 5, which is 1. I wouldn't show any more work than that. What you do is I need to find the grade. Now, obviously, I'm going to do that one. Coordinates of C was the y coordinate is 11 minus 6 over the change in y, which means 7 minus 2. So if you go back and look at the picture, if I just scroll back up quickly, you'll see it's 11 minus 6 and 7 minus 2. Now, I didn't say this in the beginning, but these were the examples that I was going to do in class. So literally, I would hit pause and draw this picture, and then I'd write down all the questions like you would have done in class, and then write down all the answers, because I'm assuming that these notes will be in your book as if we did them in class. Okay, now this gives you 5 over 5, which is 1. Now that's wonderful. Now, because it said prove, you actually therefore have to make a conclusion. So I should say, therefore, the gradient of AB equals the gradient of C1. So therefore, will hit pause right now and make sure that you've copied down the question and the picture and all of that, so you've got these written notes in your book. Okay, what's the next question say? Well, prove they're equal. Now that should be equal. I mean, that should be easy because all we've got to do is multiple different pairs of equations. Because I don't know which one. So this is for me. So that's 4 minus 5. It doesn't matter which one you get the answer because what I'm trying to show is that the difference is equal. So that is 5. 5 is 25. And the other one was a 5, so actually, which I think is not the simplest. Sorry. And that's not the simplest third form. Now, the reality is I don't mind which one you do because all I'm trying to do is show that this is equal. You could also use decimals. I don't like decimals because it's starting off very accurately argue that this is equal if you're using a rounded off version. So I prefer to okay, this is 15, which guess what is also 5, so that's 5 and 5 squared. Now 6 which is 10. So I wouldn't worry about third form, although if you use your calculator, you should go straight to full third form. And then I would say therefore, so it's probably only worth about 3 marks, that question. Okay, so what shape is this? So what have we shown so far? If I go up, I've shown that I have one pair of opposite sides parallel and equal. Now, tomorrow we're going to write a note on all the different properties of all the different shapes. But this is one of the properties of a parallelogram. Now, parallelograms have lots of properties. Basically, if you know that 2 pairs of opposite sides are parallel, it's a parallelogram. If you know that there's 2 pairs of opposite sides equal, it's a parallelogram. But if you know that 1 pair of opposite sides parallel, that means that it's a trapezium. It's not necessarily a parallelogram. But the moment you have 1 pair of opposite sides parallel and equal, it has to be a palm. So if you have parallel and equal just for 1 pair, that's okay. So I would say, yeah, color here. So you want me to call it a palm, but if this is a parallelogram, I would actually say parallelogram. They ask for people. I would say you have 1 pair of sides parallel and equal. You can't say opposite sides of no. So 1 pair of in the past, just by using the other gradient won't multiply together. I don't know that I'm proving it's actually 5. That's exactly what I wanted. Now which is minus 1. That's perfect. So that's how you write out the show that the reason. It's almost like this. But that's if you're trying to prove they're perpendicular. Know they're perpendicular. Okay, therefore what type of shape is ABCD? Well, let's go and have a look. What do we know now? I know it's a parallelogram, and I've just proved it. Now, I don't know if you know what shape is a parallelogram and the diagonals hit each other at 90. But once you've done a summary to learn all the properties, you will hopefully know that there's only one shape where it's a parallelogram and the diagonals hit at 90, and that's a rhombus. Now, of course, this could be a square, but don't forget a square is a type of rhombus. But at the moment, I don't know if it's a square because I don't know if the corners are 90. How do I know it's a rhombus? They come and my diagonal. They bisect. So you can say intersect, but technically. Okay, pause and so that you can go over this video and take down all these notes, and then I'll start another one for the next.